greater than 30%, that's the claim. The other one is less than or equal to 0.3. I'm going to draw up a quick picture. And it is what? 0.05 alpha, greater than over here. Anybody have it memorized by now? Do they know what this edge is? .05, one-tailed. Anybody know? It is, no, it is not. That would be if it was two-tailed and .05. It is the other one. Do you remember the other one? 1.645, yep. So there's the null over here. Okay. Now let's do this with our calculator. So you're going to hit stat. Go to tests. Okay, which one do you think we're going to pick? Nope. I know you'd think so because there's a z involved, right? But that's for means. It's the, are you saying the two-sample z-test? Is that what you have as? One proportion z-test? Yeah, that's right. One proportion z-test. The two by them, guys, that's if you're comparing two different populations. So one proportion z-test is what we're doing. P sub 0 is what your null is, so that would be 0.3 for this problem. It didn't say how many, it was what, 38% of 150 adults? Wait, no, 0.38 times 150, 57 people. All right, calc tests. What did I say, 57? 57 out of 150 said yes. This is a right-tailed test. And remember, you're going to highlight the tail. I prefer it when I hit draw, but you can just hit calculate and have it spit numbers at you, but I like to see the picture. This helps me understand it, though calculators take a little bit to think. Tells you your z-score, which is 2.14, and your p-value if you're doing it that way. So 2.14 is what we got. Did you guys get the same thing as I did? Okay, 2.14, that hit our rejection region. So what should we do? Reject the null and accept the claim that more than 30% use their phone while watching TV. All right, on the back side, we're going to do these, but this time we're going to use p-values. I figured that was something you need more practice on. Or is it not? Is p-value something that you completely understand and don't feel like you need more? Okay, so answer me this. Look at my face. If p is greater than alpha, would you accept or reject the null? Don't say it out loud. Just raise your hand if you feel like, yeah, I definitely know the answer to that. I'm absolutely certain. Okay, let's do it. All right. So the first one we're going to do is p-values and your Well, wait. Yeah. We'll do p-values and the chart. Or the table. And then for the second one, we'll do p-values and the calculator. All right, a researcher claims that 86% of college graduates say that their college degree has been a good investment. In a random sample of 1,000 graduates, 845 say their college degree has been a good investment. At alpha equals 0.1, is there enough evidence to reject the researcher's claim? Okay, so first thing I'm looking at, here's P. If P is this, Q is the smaller one. What's Q? 14%. Is 14% of 1,000 bigger than 5? Yes. All right, so NP and Q, good. H sub O, H sub A. Remember to use P's, not mu's, because mu is for a mean and P is for proportion. They claim that 86% say it. So what does that mean? What? Yeah, equals 2. So P is equal to 0.86, not equal to 0.86. The claim is this one. All right. Anybody feel like they've gotten better at making bell curves? Because I've been doing this for years and I think like I just get worse throughout the year. Anybody getting better? No? Everybody still sucks? Oh, Rihanna, you're getting better? Nice. Look at you. Good job. Natalie, were you always good at it? No. Surprising. Okay. Let's see, 10% two-tailed. So what should I be looking up in my z-score chart to figure out the edges? I feel like we struggle with this. Am I wrong? We actually don't have to look up the edges this time because we're doing p-values, but what would we look up? Because I feel like am I wrong that you guys are struggling with that? You guys are just being silent on me. You'd look up 0.05, or you could look up 0.95, right? Because here's 5%. And here's another 5%. So if you looked up 1, it would be 0.05, or you could look up 1 over here, it would be 0.95. Either way, you'd get the positive or the negative. You only have to look up 1 to be sure, but we're doing p-values this time. So all we care about is that alpha is 0.1, and we've got to decide what our p-value is. So our p-value is going to be the formula. That is going to be p hat minus p over the square root of pq divided by n, which is, we have to first figure out p hat, which is 0.845, minus 0.86 over the square root of 0.86 times 0.14 divided by 1,000. Go ahead and put that in your calculator. I think I'm going to start doing a warm-up almost every day of old stuff like permutations, combinations, binomials, stuff like that to help remind you. Would that be helpful?